In this video, I will walk you through the architecture of the data pipeline. We will also do a code walkthrough of the Lambda function. We'll check the Kibana interface. But first, let me give you a brief background of the project. While the COVID-19 pandemic spread around the world, it led to large-scale lockdowns and work-from-home policies. This moved a lot of the social conversations online, and hence the pandemic has given us a unique opportunity to monitor these conversations at a global scale. I have written 2 blog posts on the subject, one of which was tweeted by the KD Nuggets platform. This pipeline was hosted on a third-party account where we had received some AWS credits. However, since they have expired, I had taken a backup of the ES domain and shut it down. I have now redeployed it in my personal account. So let me explain the architecture of the data pipeline. We have some 1.2 billion tweets related to COVID-19. In the database, only the tweet ID is stored, which uniquely identifies each tweet. Using this ID, we call the Twitter API, which returns back a JSON object of more than 200 plus key value pairs. This is storing such a large object will take a lot of space. Hence, we have introduced a data transformation layer in the form of a Lambda function. The Lambda function selects a small subset of the properties and returns it back to the Kinesis stream. From here, the process tweets are stored or indexed in an Elasticsearch cluster. We then use Kibana as a visualization and analytics layer. Let me walk you through the data transformation layer in the form of a Lambda function. I use AWS Cloud9, which is a cloud-based IDE for writing, running, and debugging code. It's useful for deploying applications using the AWS Serverless Application Model, or SAM. Let me show you a Cloud9 environment that I have set up where I have imported the CovidStream Lambda function. The Lambda handler is the main function which reads the event stream in 5 megabytes block, which loops through each record while iterating and selecting only the properties from the positive list. This positive list is defined earlier. We then update the payload and write it back to the Kinesis stream. The Kinesis stream then indexes it in an Elasticsearch cluster where we can use a Kibana as a visualization and analytics layer. Let's open the Kibana interface. When you click on the link, you will reach the home page and we need to connect the Elasticsearch data. Let's define the index pattern. This is useful if you have multiple indices and you want to query them all. This shows that our index pattern is successful, so we press next. Now we need to configure some settings and we select the field name, which is your time filter, and press create index pattern. Our index pattern is now created, and now we can browse through the data via the discover tab. However, this shows that no results matches search criteria. This is because our data set is from 2020, so we need to update the time field. So we select the time period, that is from January 2020, to around October of the same year. And press update. This will load our entire data set, which shows that there are around 12 million documents indexed. This is the number of tweets that we have received on any single day. This is a timestamp and other details like the language of the tweet, the full text, the entities, the username, etc. All the available fields can be browsed from the left hand side. Let's now go to the dashboard section and create some visualization.